Okay, here's part 2 of the lesson. I'm not going to do all the rest of these with you. I'm going to do the even problems left on this side, and I'm going to do some of the odd, like 2 of the odd problems left on this side. So I'm going to do only 4 more problems, or I'm sorry, 5 more problems with you, and the rest you are responsible for on your own. Okay, so we're going to start with number 6. We have number 6 is if we're following our flow chart, right, we need to check first, do we have any 0 exponents? Because that's what we're looking for first. It's not on the flow chart, but we need to look for that first. So here for number 6, we do not have any 0 exponents. So we're going to look for, do we have any powers being raised to powers? And we do have that. We have this big set of parentheses. We have our small exponent on the outside. That means we have all of this being raised up to another power. So before we start tackling this, we need to break it all apart. We have 2 times a to the 4th times, what was that, b to the 6th divided by b squared, and all of that is being raised up to the 3rd power. When we are taking the power rule with fractions, we do the same thing. We take every part individually. So what that looks like is we have 2, and remember, if we have no exponent there, there's an invisible exponent of 1. We have 2 to the 1st power raised up to the 3rd. Power rule says we're going to keep that base, multiply those exponents. 1 times 3 is 3. And then we have a to the 4th raised up to the 3rd power. We keep that base and then multiply the exponents. 4 times 3 is 12. We have b to the 6th raised up to the 3rd power. Keep the base, multiply the exponents. 6 times 3 is 18. And then we also have b to the 2nd, which is also being raised up to the 3rd power. So we keep that base and we multiply the exponents. 2 times 3 is 6. That's the first step. We're going to go back up to our flow chart and see what do we do next. We took care of the powers. Do we have any negative exponents? We do not have any negative exponents here, so we go down to the next step. Do we have any like bases on the same side of the fraction bar? We do not have like bases on the same side of the fraction bar, so we're going to go up and check for what's next. Do we have any like bases on the opposite side of the fraction bar? Yes, we do. We have a b here and a b here. So it says simplify by subtracting your exponents. That is your quotient rule. So we're going to use the quotient rule to take care of those b's. Everything else just gets brought into the next part of our answer. So we still have 2 to the 3rd. We still have a to the 12th. This is where we're going to simplify those b's. B to the 12th, B to the 18th divided by B to the 6th. That's what it means. Quotient rule says we keep our base, subtract those exponents. 18 minus 6 is 12. And then that says we're all done. We would still want to check for negative exponents because we never want to leave it positive, but we don't have any. So we're going to go ahead and evaluate this and squish it back together. Remember, if you have a number that's being raised up to an exponent, you actually have to evaluate that out. 2 to the 3rd means 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So that would be an 8 as our coefficient. The other 2 variables just get squished beside it. A to the 12th, b to the 12th. There's your simplified expression. I'm going to skip down to number 8. And we're going to go through the process again. First, we check, do we have 0 exponents? And we do not here. The next thing we would check for, according to our flow chart, is do we have any powers raised up to a power? And we do. If you notice in the denominator here, you have your big set of parentheses and that small number on the side. So we're going to use our power rule. First, though, break everything apart. We have x to the 4th times y to the negative 3rd. That's being divided by x squared times z to the negative 2nd power times 3. So, or all of that's being raised up to the third power, excuse me. So we're going to take care of that power rule first. So then we have, we still have the numerator the same. So we're going to go ahead and put that x to the fourth times y to the negative third so we don't lose it. We have x squared that is raised up to the third power. And it says that we need to keep our base and we need to multiply those exponents. 2 times 3 is 6. That's being multiplied times z to the negative second power that's being raised up to the third power. We need to keep that base and multiply the exponents. Negative 2 times 3 is negative 6. All right, so we have to actually pause in our flow chart because now we have some negative exponents. So we actually have to go backwards and take care of those. Anytime you see zeros or negatives pop up, you've got to take care of them before you can continue on. So what happens with these? We end up with z to the negative third here we have to take care of. Oh, yes, because that's our next thing, right? We had our power rule, sorry. We had our power rule. The next thing would be to take care of those negative exponents. So when we have a negative exponent on the top of the fraction, it just gets flipped down to the bottom. When you have a negative exponent on the bottom of the fraction, it just gets flipped to the top. And what that looks like is we still have our x to the fourth here, but now we have times z to the sixth, because really that's 1 over z to the negative 6. When you flip it into the reciprocal, it becomes z over 1 to the 6th power, which is how that ends up on top. When you have the 1 in the numerator, that's y to the negative third over 1. When it gets flipped into your reciprocal, it becomes 1 over y to the third. So then we end up with x to the 6th times y to the positive third on the bottom. So remember, when you have a negative exponent on top, it gets flipped to the bottom. When you have a negative exponent in the denominator, it's going to get flipped into the numerator. According to our flow chart, after the negatives, we look for, do we have like bases on the same side of the fraction bar? We do not here, so we move to the next step. Do we have like bases on the opposite side of the fraction bar? And we do. We have an x here and an x here, and our flowchart says we need to use our quotient rule by subtracting those exponents. So x to the fourth divided by x to the sixth, that means you have, keep the base, x, and then subtract those exponents. This time you have 4 minus 6. Remember, we have to add the opposite, change the subtraction sign to an addition sign, change the sign of our second number. 4 plus negative 6, we actually subtract and keep the sign of the bigger number. 6 minus 4 is 2. The bigger number is negative, so we have x to the negative second power. And then that is still being multiplied times z to the sixth. And then we have y to the third on the bottom. We have another negative that popped up here. So before we can do anything else, we've got to take care of that negative. Remember, like I said over here, if you get a negative exponent in the numerator, it just flips down to the denominator. So then this actually becomes z to the sixth on top by itself. And then we're flipping that x to the bottom. X to the second power times y to the third. That's all that we have left here. Everything here has been simplified as far as it can go, so all that's left is to squish it together. Z to the sixth over x squared y to the third. All right, we're going to move on to number 10. Remember, if we have a 0, anything raised up to the 0 power, we want to take care of that first. So that means all of this is raised up to the 0 power. That means all that's left in your numerator is a 1, which is easy, right? It cuts out some of the work. And then on the bottom, we're going to go ahead and break that apart. We still have w to the third times z to the negative second power. We took care of the 0, and now we check, do we have a power raised to another power left here? And we don't. So we would go to the next step, which was the negative exponents. We have a negative exponent in the denominator. Remember, like we did in that problem just above, that if you have a negative exponent in the denominator, it just gets flipped into the numerator. So now we have z to the positive second in the numerator, because we're flipping it up, and we still have w to the third in the denominator. We don't have anything else with like basis to take care of here. This is actually our simplified expression, so everything else just canceled each other out. So I'm really running out of time. I'm not having time to actually go through all the rest of this with you, and I don't want to have to make a third video just to do it. So you guys do need to attempt these on your own, and we're going to end up doing like a check together on Monday where we kind of go over it one last time to see what do we need to do. But what you do need to do is make sure you take care of, number 7, number 9, and let me look here what ones you need to take care of here. I'm going to say take care of number 12 and number 14. Okay, so you only have 4 problems that you're responsible for on your own here. 4 problems. That is not enough. That's not a lot. You don't have to take care of number 11, and you don't have to take care of number 13. Okay, take care of those 2 on your, or those 4 on your own. They need to be finished by Monday. All right, thanks guys.